All right, so today we're going to do one more exercise in Python, and then on Friday we'll switch over to Java. I'll do a quick reintroduction to Java in the context of object-oriented programming to get us started on OOP. But otherwise, it's another final exam from a few years ago. Two weather stations periodically take temperature data samples. Each data point consists of a date time stamp in a proper ISO 8601 formatted string. And a temperature, example 76.2 degrees Fahrenheit. Data from the two weather stations is stored in two data files with the same following format where we've got the number of records that you should be paying attention to, and then it looks like it's space-separated value files now, right? The data is not necessarily in any order, right? What you need to do is produce several reports. First of all, you need to report the temperature, the minimum temperature, the maximum temperature, the mean temperature. That should be pretty straightforward. And then date reports. For the data set, you need to report the earliest data that you have and the latest data, or the most recent data that you have. And then finally, something should look familiar, inconsistent missing data reports, right? We're giving two files, and there could be errors in one or the other. Right, or discrepancies. For example, one of those files has that date time stamp there as 32.78, whereas the other one had 32.90. If it's off by more than that many degrees, then you should report it. If you have missing data, like for example, there's data in the first one that is missing in the second one, or a second one missing in the first one, then you have to report that as well. Now the catch here is that you are going to have millions of data points. I think the example that I've loaded up is going to be like 1 million or 10 million or something. We'll find out. You will not be able to solve this problem with a brute force approach where you're going through and for each element over here, we're going to check the element over here. Because if there are 1 million over here and 1 million over here, that's 1 million times 1 million, and we call them trillions, right? And that's not going to be executable in like a minute or two, right? Probably take more like hours for that. We'll find out though, right? All right, so start from scratch here. Once again, I do have input 03A. I'm not going to be able to open it up because it's like 23 megs. So A, we'll just look at the top here, and there are 1 million elements in there, right? So and there are 1 million elements in the second one, so you can't determine which one is there and which one is not. Okay. They should have been scrambled more than that, but they are definitely scrambled in the other ones, right? But these are the only two that I loaded up. Okay. Let's go ahead and start with a file here, weather report.py. Remember that sometimes you have to kick it in the butt because it doesn't appear there. All right. Okay, so I'm probably going to want to print stuff, maybe bring in pretty printing or something like that. I'm definitely going to want to use the command line arguments because I'm going to read those two files in as command line arguments. So import sys. Right? File A, name, right? Name is equal to sys of, where is it going to be? If I do say Python weather report and I do input 03A and input 03B, right? Then what is my first command line argument? It's the script file name. So where is the first command line argument that's provided? At 1, right? Because 0 is the script file name, and that's going to be sys.argv, I think. Yeah, there we go. File B name is equal to sys.argv sub 2. Okay. Now I've got my two files. I need to open them up for processing. All right. How do I open a file? Open, and I will open up file A name for the purposes of reading. Right? And if I wanted to, I could open up at the same time, but I'm going to process one and then I'm going to process the other because I don't want to copy and paste my code. We're going to do it together and put it into a function to do it for us. All right, so let's open up the file. How do I read all the lines? Read lines, I believe, and that will return lines. Now I don't want all the lines. What do I want? I want the second one followed by all the others. All right. But even then, I don't want just I don't want just the lines. What else do I want? I want to break it up. Remember what it looks like. That should be fine. More or whatever I did more. All right, I could go back over here. That's what it looks like right there. Right. So I've got an ISO 8601 date timestamp, and then I've got the temperature. So let's break it up. Right. For line in lines. And here I'll go with 1 and then the rest of them, right? I need to break it up into tokens is equal to line.split. And I won't be splitting based on a comma anymore. I will be splitting it based on a space. If you split it like that, by the way, it will split it based on nothing. That means that it'll split it up into individual characters. And that's not what I want, right? So space. And then the first one, tokens of 1, is 0. Sorry, that's the date, right? Date time, right, is equal to that. And then the second one is the temperature, right? And I want to convert that over to a double immediately, right? So what is it going to be? Float of tokens sub 1. Now question mark here. Do we want to convert this over to a date? There are date times built into Python, by the way. Python date time, right? If you want to, you can go to that trouble, right? You can read all about it if you want to. In fact, it'll be easy because it's in the ISO 8601 format, so you can go ahead and do that. And they're comparable, and you can do whatever you want with them. But guess what? Why do we use the ISO 8601? Why do I keep saying that that's the only proper way of representing dates? It's lexicographic order, right? That if I just use string comparisons, it'll be in temporal order, right? That's because it has proper leading zeros. It goes in the most significant first, just like numbers do, right? You wouldn't write your number backwards, right? The most important numbers are over here because they're the biggest. Well, the year is the biggest, then the month is the biggest, and then the day after that, and then t separated by the actual time on a 24-hour clock, right? So I'm just going to leave it as a string because most of the work is done for me as a string using lexicographic ordering. Right? All right, those are 2 pieces of data. What do you want to do with those 2 pieces of data? Well, if I've got 2 pieces of, 99.999% of the time, you've got more than 1 piece of data, you should be making a class. Do I really need to make a class at this point for this though? No, all I'm doing is a date is associated with a temperature. A date time is associated with a temperature. What if I just used a simple map, right? Temp map, and I'll call it A for now. Use a map. I'm going to map the date time, so whatever that was, right? And got an indent. Temp map of, say, date time is equal to temperature. Right? There. Right? Keep it simple, right? Now, let's 1, improve this by using more Pythonic code, and then 2, improve it again by putting it into a function because I want to do it for file B as well. Right? So how would you go about doing that? Here's my temp map. Do I really need all that code below? All I need is, what would it be? Tokens of 0 maps to temperature for, not temperature, a float of this, sorry. Replace that up here for, let's see, line, split the line here. So line dot split space along spaces for that in line. No, for line in the line. For line in line. And this is, I'm going to have to split this here. Split this and then split this for line in line. It's kind of icky. But I think I don't like that as much because now it's causing me to call the split function twice. And I'm sure that there's a more elegant way of doing it, but I'm pretty sure that that's going to be okay. Let's find out. Let's pretty print it. pprint temp map A, right? And is there a way that I can pretty print only the first like 10 of them? Well, I could say 1 to 10. Let's just go ahead and get the first 9 of them and see if it works, right? Because I don't want to print out a million things, right? And what should I have done? Python weather report, and it was input 03A and input 03B. There we go. All right, for line in lines. There we go. And that should be 1 through whatever. Oh, that's where I should have put it. Sorry, 1 is correct over here. There we go. Pprint is not defined, so what do I need to do? Import it, import pprint. There we go. Looks okay to me, right? If we wanted to, we can more that file again, input 03A, and I've got 1680, 1880, 0101, 8 a.m. in the morning, and it was 7.1 degrees. So I'm pretty confident that it works, okay? And it's way more Pythonic. It's 1 line of code. Right? Now let's make it a little bit better by putting it into a function. How do I define a function again? Def. What should I call this function? Load data, load weather data, right? And it'll take a file name, right? Oops, Pythonic name, there we go, right? Colon, and then everything would go into there, okay? All right. And then return, and I don't need A here, temp map, and then return temp map. That way I can load both of those. Yeah, go ahead.
You're opening file name.
Oh, thank you. File name. And also, what should I be doing before I return? Closing it. In fact, I should be doing that right after I read the lines. What is it? F.close. All right, there we go. Wonderful. And we've got data A is equal to load data from file name A. And then data B will be the second file. Right? There. And we can debug later on. Oh, and then what should I do? Restore that. I'm going to leave that there for now, just for debugging purposes. But remember that we did that. To do. Make this, or change this. Change 10, or remove 10, I guess. Remove 10 here. Okay? But if we want to, we can make sure that it works on file b2.pprint data b. Right? And there's, oh, not, there we go. And it looks like it's working on file b2. Okay? All right, get rid of that. Come back and remove that later on. You don't want your debugging statements there. I've not ever figured out a proper way of debugging Python in the CS50 IDE. If you have, great, go ahead. But otherwise, IDEs like PyCharm, Pycharm, I think that those have proper debuggers that allow you to walk through the program. But we'll just go with poor man's debugging for now. Right? Okay. All right. What next? Now that I've loaded everything up, let's do some temperature reports. And this is data set A. We don't have to worry about data set B. What is the minimum temperature? What is the maximum? What is the mean? Right. Okay. Well, I already have it in a map. This report doesn't concern the dates at all, right? Let me go ahead and dump all the temperatures, temps, to a list. How do I do that with a list comprehension? Temp for temp in data A dot. How do I get all the values of that map? Values. There we go. Now, how do I find the minimum? Remember, it's just a bunch of numbers. Min, right? So temp min is equal to min of temps. There we go. And what about max? Temp max is equal to, yes, there's a built-in max, temps. And by the way, you can use the same key. Like if I were doing this with books and I wanted to find the min or max, I could use the key equals lambda x and then do whatever you need to do, blah, 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 right? But since it's a built-in type, since it's just a number, all I have to do is that. What about mean? Wouldn't it be nice if there was a mean? I don't think that there is. Let's find out, just in case. I could be wrong. Nope, there is no mean. Is there AVG maybe, or average? No, but there is a sum. Don't ask me why there's no mean if there's a sum. And you would end up dividing that by what? The size of the temp list there. How do I get the size of a list in Python? Len temps, right? And then we can print those out. I'm going to go ahead and copy and paste this. Make it look nice. Print all that stuff, right? All right, report A. Now I could copy and paste that stuff, and then I could, get it to look exactly how I want to. Or what I could do is just copy paste it and put it into a multi-line formatted string. Right? And then I could go through and I could change all of these values. I think you can do a multi-line. Maybe I'm wrong. Hopefully you can do it. I mean, it's code syntax highlighting it like you can. Mean. And then finally, this one. And it's going to be temp max. And then I'm not doing anything with it. Ultimately, I need to print it. Report A. Right. There we go. Does that match my output? Did I bring in my out? I don't have my output. I can get my output. My expected output here. Where is it? Output 3. Taking forever though. There we go. All right, there it is. It should be negative. Oh yeah. Well, that's not going to match. Why? Yep, because of that to do up there. Let's go ahead and see if it matches once I have all of the records. Right. All right. Yeah, that looked right. It was negative 44, I think. Right. And then I shouldn't have closed it. We'll need it later. There it is. 1.98, good enough. Right. Okay. Cool. I do want that report, but I don't want any pretty printing. Okay. We can kick this back down to 10 if we want. I'll just leave it as is for now. I know that it works because I got the first report right. Okay. All right, what about the second report? The earliest and the most recent. Same trick. Instead of dumping values, though, what'll I be dumping? The keys in the dictionary. Right? So, dates is equal to D or date in. How do I do it for a map? What was my map called again? Data A. How do I get the keys out of that? Items would be the key value pair, so I could do something like that, but then I'd have to do like date, comma, temp. And then ultimately I'm ignoring temp. I don't, that might be a little bit less efficient, but it gets the job done. Right? There is another one that allows you to just do the keys, and that's the default. Right? There now I've got all the dates. Okay. Then I can sort them, or I can just go min-max like I did before. Right? So earliest is equal to, what is it, min of dates. Right? And because it's lexicographic, it's working. And that's the earliest, and that would, or opposite would be the what, most recent? Latest. Okay, thank you. Remember, two things are difficult in computer science. Naming things is one of them. Right? And then once again, I'm going to grab this and do a not that one, but this one, and do a multi-line string. Right? Report B is equal to formatted multi-line string, so that you can change this to the date, earliest, and this one to the latest. Do you see an immediate problem though? Right? So it'll, and then print it out. Yes, print report B. So, am I going to get the actual numbers there? I've hard-coded those numbers, right? Just given the dates, I don't have the numbers, right? So, maybe now I go back all the way to square one and I do make a class. You don't need that. If you've got the dates, what is this a map from and to again? It's mapping dates to the temperatures. So if you've got the dates here, the earliest date and the latest date, how do you get the temperatures? Data A, and then use that as a key. Earliest, right? And data A, latest. There we go. And 1680 is, there we go, and 6.5, and that's, oops, didn't want that. 1994 is the latest. Right. So I think that works too. Here's another way that you could have done it though, right? Let's see. So the way that I was about to do it was to use min and max using that lambda syntax, but that won't get you there either. This is easier, right? Because those two things are not put together. What you could have done is instead of a map, you could have had a tuple, right? A pair, the date, comma, the temperature, and then you'd have a list of those doubles of those pairs. Excuse me. And then you could have used the min and max really easy without a class. But otherwise, we got the job done. Let's move on. Right? Remember, in engineering, what's better than good? No? Oh, you've never heard this before? I think I've said it many times before. What's better than good? Good enough, right? And that was good enough. All right, so inconsistent missing data reports. So ultimately what I want to do is for each piece, each data in data A, right? Find the data in data B, right? If does not exist, then report missing, right? Otherwise, if you found it, if not equal, then report anomaly, what do we call it? Inconsistent. Consistent, right? Now, if you immediately go to a for loop here, right, rethink what you're doing, especially for your assignment. Because if I go for, I don't know, temp or date A, comma, temp A in data A, right? And I go for date B, temp B in data B, right? And I look for inconsistencies or for missing things, right? What I'll do here is I'll just say I plus plus, or I plus equals, right? Plus equals 1, right? And I'll start out I here at 0, right? I'm not actually doing any work here other than adding something. If I didn't put something there, it'd probably be either a syntax error or Python would have optimized it away and said, I'm not going to do those loops then, right? But if I do this, I'm going to be sitting here for quite a while. 1 million times 1, too many values to unpack. Wow. Too many values to unpack. Oh, dot, what was it? Items. There we go. Items. That was a syntax error, sorry. That resulted in a runtime error because there's no compiler. But I'm probably going to be sitting here for quite a while. Right? There's the date reports. Right? Why? 1 million things times 1 million things is 1 trillion operations here. Right? Don't do that. Right? I'm going to go ahead and kill this now before I'm proven wrong and it actually works or something. Right? It won't work on the grader, I'm pretty sure. But don't do something like that. Right? Now you could go, if this were C or this were Java, I would definitely be going for some sort of binary search. Sort them by date and then do a binary search by date. Right? We don't have binary search in Python, but we have maps. And maps are immediately efficient because it is always almost an instantaneous lookup if you have the key. Right? So I will restore that for each piece of data in A, right? Find that data in B. How do I find that data in B? Date A or date B, temp B. Well, the date will be the same. So we want the temp, right? Temp B is equal to data B, data A, date A. There we go. Too many datas and dates there. Right? So I'm searching for B using this key here because this is a date. Right? That gives me the temperature. Right? And if the temperature is not the same, if temp B is not equal to temp A, then I will report print inconsistent. Right? And be done with it. Right? How do I know that it's not there though? What will a map return if there's no key with that? None? Okay. So we'll do that. If temp B is none, right, then I will print missing. Okay. I'll agree with you for a second. I honestly don't remember if it returns none. I think it results in a key error, runtime exception. Right? So I can't do that. Right? But what I could do is what? I could check to see if temp B is in, I want temp A, sorry. Date A is in data B. There we go. All right. So is the date that I'm looking at right now, is that in? That looks at the keys for a map. If it were a list, it would look for that element in the list. If it were a set, it would look for that element in the set. But it looks among the keys for this. So if it is in there, then that means that it's there. Otherwise, if it is not in B, then it's missing. Right? Otherwise, it's inconsistent. Right? I think that this will actually run now. Is in, is not in. I think it's just not in then. Yeah. There we go. Because I'm doing it down here, right? Oh, I'm still doing it up here. Dang it. Otherwise, we know it's in there. So let's go ahead and get the actual temperature. And then I guess this has to be an else, right? Else. We'll get the temperature. There we go. And if they're not equal, then we print inconsistent. There we go. All right. So if it's in there, if it's not in there, it's missing. Otherwise, it's in there, so we can get it. And then if the temperatures are not the same, then we report inconsistent. Now, I still don't think that this is going to work, primarily because, missing, inconsistent, 2 pieces of data. Okay, so it worked, but it's not very satisfying because we don't have the actual data that is being printed here. So we're going to have to come back and fix that. Also, I'm using double quotes. I shouldn't be using double quotes. I should be using single quotes. Right, there we go. But also, this works because Python is doing some magic behind the scenes here. Floating point numbers, is it a very good idea to always look for strict equality between those? No, because take 1, divide by 3, and then add it 3 times. Do you get 1 back? Sometimes, sometimes not. Sometimes you get 0.999999. Sometimes you get 1.000001, right? So I'm going to build in a tolerance here. I'm going to use the math library. Is it math.abs? Right? If the absolute difference between these two is greater than, I think it was 0.001 was the handout said, right? Then we report it as inconsistent. Yeah.
Why not use math.is close?
Oh, is there? What does it do?
It checks within your specified range.
Math Python is close. Oh, so what's the default then? W3 schools. 9? Oh, so that's way, then we definitely need to provide our own. Find is close. There we go. And so it's epsilon, what, relative total or absolute total? Which was, what's the difference? Is relative tolerance, it's the maximum allowed difference between A and B relative to the larger absolute value of A or B. Okay, I think we want absolute. Right. And so we can do math.is close, and that equals that. There we go. All right. Oh, go ahead. Oh, yeah. Is it two args?
Yeah.
A, B, and then that. Okay. There we go. I should still get 2. No, what's wrong? Import math. Thank you. Technically, I should be going in alphabetical order. That LMNOP. So import math. All right. I think the Pythonic way is to organize them in some manner. Oh, now it's all inconsistent. Don't want that. So I used this wrong somehow. Maybe it's relative. Maybe it is relative. Oh, why? What was wrong? Rel total. Yeah. All right. I don't want to figure that out right now, so I'm going to go back to my solution. undo it. Oh, I can't do undos? All right, fine. Math dot absolute value. The difference is greater than that. All right. If you know what I was doing wrong immediately, just go ahead and let me know. Otherwise, come on. Fabs?
Oh, yeah.
Really?
It's floating.
Let's check that out. Fabs. Is there no abs? Okay. There is no abs because it'll just take, you just use fabs. Oh, yeah, it's part of the standard library. That's one of those historic quirks of why the hell would you do that, right? The standard library can handle, the abs can? Okay. Okay, hopefully that works. All right, so missing and inconsistent. What else do we need to print here? The temperatures and then the date, the common date. So inconsistent would be, that would be date A, and, or that, sorry, temperature A, temp A versus temp B, and the date in parentheses here. So that'd be date A. There we go. And I need to make this into a F string, a formatted string, and I need to make this into a formatted string, and then the missing would be, the format there would be, yeah, just the temperature, so temp A, and then the date. Oops, that'd be date A. Okay. Run that again, and you notice here that it's almost instantaneous, right? Doing 1 million records, because you're not doing for 1 million records, 1 million records over here. You're doing 1 million for 1 million records. We jump immediately to the location or not, right? Because it's using hash-based data structures, it's an instantaneous jump on the second one. So we are doing 1 million operations, but we're not doing 1 million times 1 million operations. Okay, and I think that that's probably it, right? Does it look right? Yep, it's even in the same order. Yay. Okay. I don't think that we put it, but is there anything in B that's missing in A? I guess we didn't require that, but you could do the same. What would you do? Switch everything around from B to B, et cetera, et cetera. Or here's another way. Right? C, data missing from B in A is equal, that's terrible, missing, let's just go with missing. Right? Data B minus data A. Right? And let's pretty print missing. What did I do there? Oh, come on, really not a dictionary? Yeah, well, dot keys. That's not very satisfying because this will end up as a set. There. And there's what's missing in B, or that's what's in B that is missing from A. And all I did was, have you gotten to sets yet in 235? What are you doing in 235? That's discrete math. Logic, proofs? Yeah. Okay. When you eventually get to sets, this is the set difference. The key there, I've got a keys, which is a set over here. I've got keys over here. So what that is, it's going to be set minus visual diagram, right? Or a Venn diagram. There we go. There we go. Ugly, but whatever. So it's everything in A minus everything in B. Right? This would be everything in B minus everything in A. And you can do that with sets in Python. Can't do it with dictionaries apparently, but whatever. Right? So there's a one quick liner that you could have done. We could have done that up here as well, but we wouldn't have been able to do the inconsistent data doing something like that. Unless we made a class. If we went all the way back at the beginning, made a class that had those two things, properly made it into a total ordering, and everything that like we did with the books, then you could probably cut this down even further to like maybe 10 or 15 lines of code. Right? All right. Any questions? Otherwise, yeah, there's stuff in B missing in A using set minus set difference. Okay. All right. That's all I had. What more do you want to do in Python? Nothing? All right. I don't know, advanced Python? What now? Darn it, I even forget what it is. Pickle, that's it. Python, pickle. Right. Say what? You've never heard of Python pickle? No. Okay. So, it's not a game or anything like that. It's a package that's part of the Python library. It is a way that you can take data and then store it out to a file, but still in a Pythonic format. It basically takes, if I wanted to store a dictionary or something, looks like it does it in JSON maybe internally, or there, dump or load or something like that. All right, you can dump data out to a file, and I've done this all the time. I don't want to have to load up the data again in a format or something like that, and so I've got the dictionary that I want to work with in future runs of my program. So I'll just dump it to a file, and then you just use one line to restore that file to the dictionary. Right? That's called serialization, deserialization. And that's actually something that you're going to do in assignment 1.0 a couple weeks from now. But there's Python pickle. There is, what else is there? Python connect to a database. Actually, just go a server, HTTP server, right? HTTPS server. No, I don't want that. I think I could just do it with, can I do it with just a file? So F is equal open HTTPS ESPN.com. There we go. For the purposes of reading. You should be able to do this. I can do this in other languages, but can you do this in Python? Print F? I don't, you probably can't do this. This is way too complicated for it. Yeah, there's no such file. All right. So I mentioned this because this is something you can do in PHP. If you just do fopen, you can open up anything in any protocol that's supported. Some other things that you would want to do are maybe SMTP, right? What is SMTP? Yeah, email, simple mail transfer protocol. So you could open up a connection to an email server and write an email in Python. In PHP, you can't do that apparently in Python. Another one would be SFTP. That's file transfer protocol, but the S in front of it makes it secure file transfer protocol. What else have I done? Yeah. Anyway, I don't know any other advanced Python. Bringing in libraries, and that like NumPy or NumPy, statistical libraries like stats or SciPy is another one. SciPy. Right? If you have to do anything scientific, SciPy has a whole bunch of packages in there for you. Yeah.
SSH.
You could, but then you need to log in, and how is it doing that? You could, yeah, I don't know. Yeah, I'm sure that you could. I mean, all you need to do is follow the protocol. You can do whatever you want. Just that you have to load up, write code to do it. Can you open up a raw socket connection, raw Python? So I just want a raw socket connection, raw. Can you? All right, F tool. Right, and there you go. There's a raw socket connection in Python, but you're going to be writing a whole bunch of protocol stuff manually, and I wouldn't do that. But yeah, you can open up a raw socket using, what is it called? F tool? No, that's not right. It's a socket. There you go. Socket. SciPy. There's graphing stuff. Graphing Pi. But yeah. All right. No questions? All right, then remember, Friday we will move over to Java, do a quick review. But Friday also is your first assignment is due by midnight. Next week on Monday, we will have folks from the Writing Center coming in, and we're going to talk about technical writing because not this Friday, but the Friday after that, that's when your first draft of your technical design document is due. Don't get writer's block or think, oh wow, I've got to write an entire document in 1 week. No, you're writing the first draft, and the first draft only covers the first phase of the project. You're going to have 7 other drafts that you're going to be turning in over the semester. Right? So it's not a lot that you have to write for the first one. And besides, with technical writing, you don't want to write a lot. Technical writing is all about brevity and writing as little as possible, just like code. Right? Yep. All right. I'll see you on Friday then.